We're now going to graph a conic section whose equation is a polar equation. We have that r equals 9 divided by 3 minus 6 cosine of theta. What I'm going to do is divide the numerator and denominator by 3, and I obtain 3 divided by 1 minus 2 cosine of theta. The reason that I divided the numerator and denominator by 3 was to write the equation in the form r equals EP divided by 1 minus e cosine of theta. Now I can see by inspection that e is equal to 2, and I can see that e times p is equal to 3. Because e is 2, I have that 2p equals 3, and p is equal to 3 halves. This is the equation of a hyperbola because of the fact that p equals 3 halves is greater than 1. It's a hyperbola whose transverse axis is going to be along the polar axis. That means that the branches of the hyperbola are going to open to the left and to the right in the Cartesian plane. To find the vertices, what I need to do is let theta equal 0 and let theta equal pi, because these are going to give me angles whose terminal side is on the polar axis. When theta equals 0, I get that r equals 3 divided by 1 minus 2 times the cosine of 0. The cosine of 0 is 1, so I have 3 divided by 1 minus 2 times 1, which is 3 divided by 1 minus 2, which is 3 divided by negative 1, or negative 3. Now, when theta is equal to pi, I have that r equals 3 divided by 1 minus 2 times the cosine of pi. The cosine of pi is negative 1, so I have 3 divided by 1 minus 2 times negative 1. Negative 2 times negative 1 is plus 2, so I have 3 divided by 1 plus 2, 3 over 3, or just 1. What that means is that my vertices are located at negative 3, 0, and at 1, pi. What I want to do next is find the midpoint of these vertices so that I know where the center of my hyperbola is. I'll slide this paper up so I continue along. The midpoint of the vertices is easiest to find by drawing a little graph so that you can visualize the results. In polar coordinates, negative 3, 0, I have the terminal side of the angle is on the polar axis, but then I go 3 units in the opposite direction, so there's one of my vertices. For 1, pi, I draw my angle of pi, and then go 1 unit from the pole to this point right here, 1, pi. For that reason, the midpoint of these 2 points is right here at negative 2, 0 in rectangular coordinates, but it's the point 2, pi in polar coordinates. So the center of my hyperbola is at the point 2, pi. The reason I wanted to find the center was so that I could determine the value of A, the distance from the center to a vertex. The distance from the center to a vertex A is 1 unit. Because of the fact that E equals C over A, I can then find the value of C. Here's how I can do that. I know from earlier in the problem that the eccentricity E is equal to 2, and I just learned that A is equal to 1, so now I know that C is equal to 2. What that is going to allow me to do is figure out the value of B squared. Remember, in a hyperbola, C squared equals A squared plus B squared. That means that B squared is going to be C squared minus A squared. So I'm going to have 2 squared, or 4, minus 1 squared, 1, is 3. So b is equal to plus or minus the square root of 3. Remember, this is going to help me to draw the graph of the hyperbola because I'm going to plot points square root of 3 units above and below the center. It's above and below the center because the branches open left and right on the hyperbola. If I put all this information together, I obtain the graph of the hyperbola. What I've done here is plotted my vertices at 1 comma pi and negative 3 comma 0. I have my center labeled, and what I could do is plot points square root of 3 units above and square root of 3 units below the center. If I drew in my rectangle, that would allow me to draw in the asymptotes, and then by drawing in the asymptotes, I can easily trace in the graph of the hyperbola.